applications which do not require speed control. They require torque to be controlled. And in that case, speed will help in maintaining the desired torque. Imagine that there is a product which requires tension to be maintained. We will take an example of paper rolling machine, where if the tension is greater, the paper will get torn apart. And if the tension is less, the paper will be loose and the finishing of the roll will be in bad shape. So for illustration, I have shown here so you get the idea. These two lines which illustrates the paper is either loose or too tight, and this green one shows the paper in proper stretch. So now we understood the purpose. So first thing I want to tell you is that such applications are rare, and most probably you will get a chance to apply this function in plastic film or paper rolling machine. Here I will show you the demo and we will understand the actual working. I am using IS7 series drive because it has vector control option. Now you notice here the torque, that is the torque which we set, that is our desired torque. Here notice the speed is regulated as the actual torque varies. If torque becomes greater, the speed is reduced, and in case torque is reduced, the speed increases. So this way the torque is maintained. Now how we know the torque? Well, it is related to the amperes. In case amperes increases, that means more stretch or more power is applied on the shaft of the motor. And in case ampere decreases, that means the sheet is loose. For setup, as a first step, I will select the method. It could be vector control which has encoder feedback, or in case we do not have encoder, which I personally do not recommend. But in case encoder is not available, then we will select sensorless vector control. And for your information, if you want to use sensorless vector control, then a lot of fine tuning will be required, which will be in the form of setting P gain and I time, and then test the system. And in case the result is not good, then P and I must be set again. So for this reason, if you can use encoder feedback, and all the hassle will be avoided. Then we need to enter motor data. After that, we need to make auto tuning. So as we studied in previous videos, that there are two types of tuning. One is rotational tuning and second is standstill tuning. So based on your site condition, you can select. The rotational tuning is more accurate, but in case it is not possible, then standstill tuning can be performed. Once finished with tuning, we need to enable torque control. Finally, we need to set the target. We need to tell the VFD what is the desired torque we need to maintain. In this video, I will not go into detail because all the things we have covered in vector control video. So if I repeat details again, it will be inappropriate. So these are the parameters which we should consider for this application. And one more point, that you do not need to worry about remembering the parameters or how to find this bunch of parameters. Simply you will search in the manual torque control, and manual will indicate the page number. Once on that page number, you will find all these parameters together. For your verification, I have attached in the resources the page of the manual. Now the first step is to define the control method. Is it sensorless or vector? Second step is to set all motor parameters accurately. And the third step is to make auto tuning. And in fourth step, enable the torque control and select the torque command source. You need to select that you want to use the keypad to set the torque value or analog signal. Once all this is done, then run and test it.